This is chapter 11-1. We are putting it in between 6.1 and 6.2, chapter 6.1 and 6.2. After we finish 11.1, we'll go back to chapter 6-2. Chapter 11.1, angle, measures, and polygons. Please copy your cuts. Alright, to begin this lesson, we need to look at a few things here. First of all, let's say we want to determine what the interior measures of any polygon is going to be. It's simple to do if we use Theorem 11.1, which is Polygon Interior Angles Theorem. The sum of the measures of an interior angle of a convex polygon, I have n-gon, is n minus 2 times 180 degrees, which is the equation I will be using, where n is the number of sides on the polygon, or we can use 180 degrees plus n minus 3 times 180 degrees. Well, what am I asking? Remember, I said I'm trying to find the interior angle measure. So let's say I have this pentagon here, and I want to know what the interior angle measures total, or the sum, is. For example, when we have a triangle, we know that the interior sum is supposed to equal 180 degrees. Quadrilateral, at this particular time, you should know that the quadrilateral is equal to 360 degrees. Well, what if I have a pentagon or dodecagon, and I need to know the interior angle measures of any of those polygons? Well, we use this equation here, or you can use this one, but I will use the n minus 2 times 180 degrees. Well, if I have the pentagon and I want to know what the measure of this angle plus the measure of this angle plus the measure of this angle plus the measure of this angle here, and finally the measure of this angle right here, I can find the interior angle measures using this Polygon Interior Angles Theorem, n minus 2 times 180 degrees. Well, let's suppose we do have this polygon, and we need to remember that it's a 5-sided, therefore it's called a pentagon. And using the Polygon Interior Angles Theorem, I can find out what the interior angles of a pentagon is going to be using the equation n minus 2 times 180 degrees. In this particular case, n is equal to 5 because I have 5 sides here. So that means I'm going to, by substitution for n, I'm going to put in 5 minus the 2 times 180 degrees. Parentheses first, 5 minus 2 is 3 times 180 degrees. Therefore, the interior angles is going to equal 540 degrees. Okay. Let's suppose I have a 15-sided polygon. Again, I still use the Polygon Interior Angles Theorem, the n minus 2 times 180 degrees. In this particular example, n is equal to 15, so I'm going to substitute in 15 for n, and I have 15 minus 2 times 180 degrees. 15 minus 2, because it's in parentheses first, is 13 times 180 degrees, which equals 2,340 degrees if I had a 15-sided polygon. Okay? Next item of business. Let's recall exterior angles in the exterior angle theorem. Let's recall that the exterior angle theorem says that, first of all, we look at the exterior angle on this triangle for ABC. The exterior angle is angle 4. And the rule for the exterior angle theorem says that the measure of angle A, plus the measure of angle B equals the measure of angle 4, the exterior angle. So again, angle A plus B is equal to angle 4, which is the exterior angle. Well, on polygons, if I have a pentagon, if I have a hexagon or a heptagon, I can calculate what the exterior angle will be. Now, it's not going to be A plus B is equal to that exterior angle anymore. We use this only for triangles. The measure of angle A plus the measure of angle B equals the exterior angle. We've got to do a little bit more work when it comes to another shaped polygon. Well, I'm going to use a corollary, try saying that fast, Theorem 11.2, which is the Polygon Exterior Angles Theorem. And that just simply says when I have a regular, hopefully you know, remember regular, same equal angular and equilateral. I can use 360 degrees divided by n, where n is the number of sides. So let's suppose I wanted this exterior angle here. Well, count the sides, 1, 2, 3, 4, 5 on this pentagon here. Because it's 5-sided, I can find out what this exterior angle will be equivalent to. Again, and it's 5 because there are 5 sides on this regular, equal angular, and equilateral on this 5-sided polygon. So that means 360 degrees. I'm substituting here, bringing it down. Where n is equal to 5, so 360 degrees divided by 5. X will be equal to 72 degrees. That means that x will equal 72 degrees. And that's your 11-1 lesson.